So this was DSA. So we'll start from reverse today. Okay, write a program to explain JDBC batch processing. We import java.sql first and create a class called fetch records. And inside of this, there's class.forName, which takes oracle.jdbc.driver.oracle driver. And then we create a connection using the get connection method, which takes JDBC Oracle thin at localhost, whatever that is, system and Oracle. And then we set the auto commit to false. I think we do that probably because we are doing batching of the queries. Then we create a statement and you hold that in statement. Statement has a method called add batch. We add a couple of queries into that. You can write whatever query you want to. In this case, it is insert into user with values of so and so. And then you execute the batch using execute batch statement function. And then you commit and then you close. And so here we are making this auto commit to false, and at the end we are manually committing it once the query is going to be executed. Okay. Yep, JDBC batch processing. So basically we batch multiple queries into one for performance purposes, because if they are the queries are requested like multiple times, it will take more time, so it's not very efficient. It makes performance fast. It is because one sends multiple statements of SQL at once the database. The communication overhead is reduced significantly as one is not communicating with the database frequently, which turns into fast performance. So the reason for the fast performance is that we're not communicating with the database frequently, and we're reducing the communication overhead. Fast performance. Okay, then java.sql statement and java.prepared sql.prepared statement interfaces provide methods for batch processing. So we have add batch, which is used to single statements to a batch. And then we have execute batch, which begins the execution of all the group together statements. The method returns an integer, and each of the elements in the array represents the updated count of the respective update statement. And this is used to clear the batch, removes all the statements. So adding a batch, executing the batch, and removing the batch. Which day is Ganpati, do you know?
No, I don't know.
Starts today, I guess. That's why. The reason I asked because it's going to be a lot of noise. Okay, let's see. Batch processing is done. Go to JDBC driver manager. Let's try to recall. I think it tries to manage all the drivers. Let's see. Is a concrete Java class provides an interface between the user and the drivers. The driver can create database connections, but generally driver managers use to get the connection. So it gets the connection, provides elementary services to maintain the JDBC drivers, and defines an object that connects the application to the driver. Manages various drivers, yeah, like I said. Tracks the available drivers, so managing and tracking the drivers. So it's called driver manager, so we derive driver word from that, and we say that it manages and tracks. So manages various drivers running on an application, tracks available drivers, and appropriately chooses the one which connects the application with the database. Driver manager.get connection method is most commonly used method of this class to establish database connection. Okay, so used to get the connection, and the way it does it uses the get connection method to establish that database connection. I think we should put this this guy over here after this because it's linked to that. Both are talking about get connection. So it provides an interface between drivers. Okay. So again, the keyword driver is derived from the fact that it's a driver manager. So it provides an interface between the users and the drivers. It manages the drivers on running on an application, and is used to get the connection by using the get connection method. Provides elementary service to maintain JDBC drivers, defines object that connects the application to the driver, manages various drivers running on an application, and tracks the drivers. Okay. And appropriately chooses which connects the application, the one which connects the application with the database. Class.forName is used to load the driver. So in the previous program, we saw that we were using class.forName, and the reason for using that was because it's used to load the driver. Because unless we load the driver, we can't get the connection. So we have to load the driver first. forName com.mysql.cj.jdbc.driver. Okay, driver manager class example. We instantiate the driver using com.mysql.jdbc.driver, and then we register the driver by calling a method on driver manager, and we print saying that driver successfully registered. The register driver method of the driver manager class is used. Yeah, driver manager class registers the given driver. I think they should have imported the driver manager class on top. It's not anywhere here. If the driver is null, it returns the null pointer exception. And they're throwing exception here. Okay, moving on. What is JDBC? Java database connectivity. JDBC API used to provide database connectivity between Java applications and various databases. So provide database connectivity. So the definition is in the full form itself. JDBC is Java database connectivity, and this API is used to provide database connectivity between Java application and various databases. It defines how to access the RDBMS through standard interfaces and classes. This API helps us to write Java applications that can access tabular data, and it allows Java applications to access various types of database like Oracle, MS Access, MySQL, SQL Server, IBM DB2. It offers platform independent interface between the Java application and the RDBMS, and follows the application to execute SQL statement. Various tasks are associated with database usage, such as establishing connection, query creation, query execution, and viewing and modifying the resulting records. It provides two packages, java.sql and javax.sql. It provides database connectivity between Java application and various databases. Defines how to access RDBMS through standard interfaces and classes. Helps to write Java application that can access tabular data. Allows Java application to access various types of databases. So key thing is it's Java database connectivity. So provides this connectivity, this database connectivity between Java application and various databases. So provides database connectivity between Java applications and various databases. Defines how to access the RDBMS through standard interfaces and classes. Helps to write Java applications that can access tabular data. Allows Java application to access various types of databases. Offers platform independent interface. Java application RDBMS allows the application to execute SQL statements. Various tasks related with database usage, such as establishing a connection, query creation, query execution, viewing, modifying resulting records. So basically, when we get this question, the first thing is that we derive the definition from the full form itself, which is provides the database connectivity between Java and other applications, and then we say it defines to use the RDBMS, and then we just talk about different operations on databases, like it helps in the query execution, query manipulation, all of those stuff, and about the tabular data, etc. Defines how to access RDBMS, helps to write Java application that can access tabular data, allows Java application to access various types of databases, offers platform independence interface. Various tasks are associated with the database usage, such as establishing a connection, query creation, query execution, viewing and modifying the resulting records. And it provides two packages, java.sql and javax.sql. Advantages: providing existing enterprise data. So businesses can continue to use their installed databases and access information even if it is stored on a different database management systems. Okay. Simplified enterprise development. The combination of Java API and the JDBC API makes application development easy and cost effective, and zero configuration of the network computer. So no configuration is required on the client side. Driver is written in Java, so all the information needed to make the connection is completely defined by JDBC URL or by a data source object. Full access to metadata. The underlying facility and the capabilities of a specific database connection need to be understood. The JDBC API provides metadata access that enables development of sophisticated applications. No installation. A pure JDBC technology-based driver does not require special installation, and JDBC connection identified by URL includes a way to identify and connect to a data source. Sumaya, let's read this once and then we'll move on to the next one.
Okay. Advantages of JDBC: provide existing enterprise data. Businesses can continue to use their installed databases and access information even if it is stored on different database management systems. Simplified enterprise development. The combination of the Java API and the JDBC API makes application development easy and cost-effective. Zero configuration for network computers. No configuration is required on the client side. Centralizes software maintenance. Driver is written in Java, so all the information needed to make a connection is completely defined by the JDBC URL or by data source object. Data source object is registered with the Java naming and directory interface naming service. Full access to metadata. The underlying facilities and capabilities of a specific database connection need to be understood. The JDBC API provides metadata access that enables the development of sophisticated applications. No installation. A pure JDBC technology-based driver does not require special installation. Database connection identified by URL. The JDBC API includes a way to identify and connect a data source using a data source object. This makes code even more portable and easier to maintain.
Okay, so it's providing existing enterprise data so businesses can not only access the database information on their own databases, but also the ones which are stored on different database management system. Uh, it provides simplified enterprise development, which means the combination of the Java API and JDBC API makes application development easy and cost effective. So it provides existing enterprise data, and the combination of Java and JDBC API is making the development easy. Zero configuration for network computers, so no configuration is required on client side. Centralizes software maintenance. Full access to metadata. So it provides metadata access and enables the development of sophisticated applications. No installation. A pure JDBC technology driver does not require special installation. Okay. Database connection identified by URL. It includes a way to identify and connect to a data source. Cool. Event handling in Java FX with example. Uh, so I think the event is generated when the user interacts with the application nodes. Event handling is a mechanism that controls the event. So first we describe what the event is. Like an event is fired when the user interacts with a particular node on the screen, and the event handling is the mechanism to control those events and decide what should happen if an event occurs. JavaX provides JavaFX.event package for basic framework of FX events. Do you remember the package names for JDBC that Java provides based on what we just studied?
I'm not sure.
One is Java dot SQL, and second is JavaFX.SQL. Let go.
It's java.sql.
Yeah, and then JavaX.SQL, something like that. One second, just checking. Where did that go? I read it, just read it just a while ago. Yeah, here it is. JavaX.SQL. Okay. So we remove in Java FX, we remove the F, so it becomes JavaX and .SQL. So these are two packages that JDBC provides. Coming back on the event. So an event is triggered when a user interacts with a node, and the mechanism to handle what happens when the event is fired what should happen if when a user interacts with that particular element. That is the event handling. JavaFX provides JavaFX.event package for basic framework of FX events. The event class works as the base class for JavaFX events. Each event is associated with source. A source is an object that generates an event and sends it to one or more listeners. And target, once listener receive this event, they process the event and then returns. A target listener can be window, scene, and a node. Type, the type of the occurred event, what type of it is. Example, action event, mouse event, key event. So the event is associated with three things. One is source, on which the event occurs. So source is an object that generates the event and sends it to one or more listeners. Why we are saying one or more listeners? Because uh, there might be that multiple things happens after you click the button. So there may be multiple events which are latched to or registered to that particular element, which is the source. Okay. So, for example, once you submit a form, one action could be sending a request to the API, which is with all the information the user had entered. Another action could be showing a thank you message, removing that particular um, removing that particular element. So there could be click event. There could also be hover event on the same element. Like if you hover on that particular element, then some animation should occur. So it's like it's the same object, same source, but there are multiple. It's attached to multiple event listeners. So that's why it's saying that a source is an object that generates an event and sends it to one or more listeners. Then you have the target. Once listener receives this event, they process the event and then returns. A target listener can be window, scene, and a node. Type of the occurred event, for example, action event, mouse event, key event. So I don't know why they're calling it target. They're confusing with source and target. They should just call it listener. So yeah, they whatever is listening to that event and going to fire something. Okay. So Sumaya, let's just quickly read this and then we'll recap.
Event handling in JavaFX. In JavaFX applications, an event is generated when the user interacts with the application nodes. Event handling is the mechanism that controls the event and decides what should happen if an event occurs. JavaFX provides a JavaFX.event package for basic framework of FX events. The event class works as the base class for JavaFX events. Each event is associated with source. A source is an object that generates an event and sends it to one or more listeners. Target or listener, once the listeners received the event, they process the event and then return. A target or listener can be a window, scene, and a node. Type Type of the occurred event, example action event, button is pressed, mouse event, mouse activity, key event, keystroke has occurred.
Okay. Do you want to read once again before we recap, or you kind of got that?
No, I try to remember.
Sorry.
No, I try to remember.
Okay. So what's an event?
Um, an event is generated in JavaFX when a user interacts with a node.
Okay. Application node. And what is event handling?
Event handling is used to uh, define what should happen when some event occurs.
Correct. It's a mechanism that decide what action to be performed when an event occurs, and what package is used in Java for event handling.
Mm, JavaFX.event handler.
Correct. No, no, just event.
Okay.
JavaFX.event. And what are the three components of this event handling or event?
We have source, which
Hmm.
is the object
Generates the
that
event.
sends that generates the event, and a target or listener, uh, which is listening for the event,
Hmm.
and uh,
And there could be different target or listeners. For example, window,
yeah,
scene, and node. Okay, and third thing.
and the type of the event,
Correct.
like a keystroke or mouse event.
Okay. Okay. Mouse event and key action event also. Uh, okay. The event is called key event. You can give example keystroke. Okay.
Okay.
So event is called key event, action event, mouse event. So basically, whatever that object is, uh, you say event after that. So if it's key, then it's key event. If it's mouse, then it's mouse event. And then action is kind of more generic, like a button is pressed or something. Okay, so event is generated when the user interacts with the application nodes in JavaFX applications. Event handling is a mechanism that controls the events and decides what should happen if an event occurs. JavaFX provides JavaFX.event package for basic frameworks of FX events. Event class works as base class for JavaFX events. Each event is associated with the source. Source is an object that generates an event and sends it to one or more listeners. Once the listener receives this event, they process the event and returns. Um, okay, once the listener receives the event, they process the event and then return. Target can be window scene and node. Type of this occurred event, example action event, mouse event, and key event. Okay, when a source generates an event, JavaFX application goes through four stages for event handling. One is target selection. When any user interacts with the UI control, then an action occurs. At that moment, system decides which node gets the focus. Route construction. When an event is generated, the default or initial route of the event is determined by construction of an event dispatch chain. It is the path from the stage to the source node. Event capturing and event bubbling. So event capturing, then the root node of the application dispatches the event. This event travels to all the nodes in the dispatch chain. If any of these nodes has a filter registered for the generated event, it will be executed. And then event bubbling. In bubbling phase, the event is traveled from the target node to the stage node from bottom to top. If any of the node in the event dispatch chain has a handler registered, it will be executed. I think it'll be nice to put a diagram there. Stages for event. Let's make it easier. It's showing me that event in Java. I have to write in Java. Do they have? No.
There is a diagram in the book. I think I'll put that.
Can you put that?
Yeah.
Okay. Yeah, is it showing all those four things that we spoke about?
I'm checking.
Okay.
It has a diagram for event dispatch route.
Oh no, we need the full one. So much of ads going on. Can't even see anything. I think I found one. I think I found it.
Okay.
See this. That's capturing, that's target, that's bubbling. How many did we have?
Yeah, this is good.
Target, route, capture, and bubble. We didn't have the route here. Let's see. And there's another one. Target, bubble, capture. Route is not showing. Capture, target, bubble.
I think the route is shown by the arrows.
Okay. Okay. I want to go for the simplest one. So I'm looking for the best one here. I think this is good. What do you think? It's like a simple one.
Yes, it's good.
Let's try that. Yeah. So when a source generates an event, like in this case, source, this is the source, I guess, goes through four stages. First is the target selection. Okay. When any user interacts with the UI controls, then an action occurs. At that moment, system decides which node gets the focus. Then route construction. When an event is generated, default initial route of the event is determined by the construction of event dispatch chain. I think chaining will be a better example then. Mm, maybe let's put both for now and we'll decide later which one to. Do we have space actually? We don't may not have space. Skip this only then. One, just one. Yeah. So capture phase, this was the target, and then bubbling phase. When any user interacts with the UI control, then an action occurs. At that moment, system decides which nodes gets the focus. Like in this case, this TD is getting the focus. Route construction, when an event is generated, default initial route of the event is determined by the construction of an event dispatch chain. It is the path from the stage to the source node. Perhaps we need something in Java because we need stage. We'll find out later. In the book, it's not there, right? This capture and target and bubbling.
No.
What if I put Java here? Will I get it?
or Java FX.
Yeah, Java FX will be better actually. Yeah, looks like event handler, fire add event learner, fires. It's not there. Fine, probably will search for it later. It's taking time. But we can definitely not draw this diagram for sure because in Java we have stage and all. Okay, it is the path from the stage to the source node, event capturing. Then the root node of the application dispatches the event. So I think from here the event is dispatched. This event travels to all the nodes in the dispatch chain. So I think it travels from top, I guess. Root node of the application. Yeah, root node means the top dispatches the event. So I think it's dispatching. And this event travels to all the nodes in the dispatch chain. So it's traveling to all the nodes in the dispatch chain. If any of the nodes has a filter registered for the generator, it will be executed. So like when it's dispatched, then it's going to each and every node, and one of them, if they have a listener attached to it, then that will be fired. In this case, when it's traversing, doesn't find any of the elements having the event, so it's not going to do anything until it finds TD. So that's where it gets that, and it's going to fire whatever event has been attached to this TD. Event bubbling. In event bubbling phase, the event is traveled from the target node to the stage node from bottom to top. If any node in the event dispatches the chain, if any of the nodes in the event dispatch chain has a handle registered for the generated event, it will be executed. Okay. So again, in the bubbling phase, I guess also it's going to look for any event that's attached. But I don't know how these two are different, the capturing and bubbling, that we have to understand. Okay, let's kind of break this so that we can try to remember. So when a source generates the event, so four stages. Application goes through four stages. First, when user interacts with UI control, then action occurs. So user interacts with UI control, action occurs, system decides which node gets focus, event generated, initial route determined by construction of event dispatch chain, path from stage to source. Okay. Then root node of the application dispatches the event. So root node dispatches the event. The event travels to all the nodes in the dispatch chain. Okay. Event travels to all the nodes in dispatch chain. Any node has a filter, it will be executed. Will be executed. In event bubbling, event travels from target to stage, bottom to top. Any node in the dispatch chain as handler will be executed. We have put it to the minimum we can kind of abstract from the big content. So when a source is generated, an event application goes through four stages. One is target selection. When any user interacts with UI control, action occurs. System decides which node gets the focus. Okay, so whenever a source generates an event, there are four stages. First is target selection, then you have uh, capture phase, and then bubbling phase. Sorry, I'm missing one phase here. Target selection, which is the other one?
Route construction.
Route construction, yes, which is this route construction. So target selection, deciding which element gets the focus. Route construction from route up until that element, and in between, if it finds that any filters attached to that particular node, then uh, the bubbling phase, in which it travels from that particular node up until the root, and while it traverses through this chain of route, if it encounters any events or listeners attached to these elements, then those will be executed. Okay, I think we've got at least the gist of it. So, Maya, do you want to read and try, or you're comfortable trying it?
I'll try.
Okay, go ahead.
So event handling is done in four stages. The
Hmm.
first is target selection, uh,
Hmm.
uh, which decides which
Get the
node will
focus.
respond to the event, which node will
Yeah,
get
which,
focus.
yeah, see, it's glowing, right? So you can think that it's got the focus. It's in focus now.
Mhm. And then we have route construction, which is to um, create a path from the root node to the target node.
Yep.
And then
No,
event.
no, no. Before we jump into that, there's a point here we are missing. That once the route constructed, what will happen during the its journey from that root node to the target? What will happen in case if any of those elements have a filter attached to them? Then those will be executed, right?
Yes.
Yes. Okay. Carry
And
on.
last is event bubbling.
Hmm.
So the uh, the event travels from the target node up to the root node, and if any of the nodes have a listener, then the event handler will get executed.
Perfect. So I think with the help of this diagram, we can easily explain in the examination. You just have to remember
Yeah.
the phases, the four phases when a source generates an event.
What
The
was the
application.
third phase?
Yeah, so first phase is target selection, second phase is the route construction, third is the capture phase, and fourth is
Okay.
the bubbling phase. Okay, so
Okay.
any user interacts with the UI control and action occurs, that moment system decides which node get the focus. Route construction when event is generated. Okay, I think in this route construction, the I think that part doesn't happen. The firing happens in capture phase. Route is just the construction of route. So when event is generated, initial route of the event is determined by construction of an event dispatch chain. I think we should remember this point. Construction of event dispatch chain. Okay. So in route construction, when event is generated, initial route is determined by the construction of event dispatch chain. What is event dispatch chain? It is the path from the stage node to the source node, from the stage to the source. Sorry, stage. I think it's the root basically. Then the root node of the application dispatches the event. So now, so first the path will be created in the route construction. Then the event will be dispatched from the top, from the root. The event travels to all the nodes. So that event is traveling to all the nodes. If any node has a filter registered for that event, it will be executed. In event bubbling phase, event is traveled from target node to the stage. I think the key difference between these two guys is that in both cases, event is traveling from one point to another. The difference is that in the capture phase, the event is traveling from the root to the target, but in bubbling, it's moving from target to root. Okay, so in both stages the traversal is going to happen, but it just in the order in which it happens. Why do I think like that? We have discussed this sometime back. This part feels like I've discussed this, but anyways.
No, we didn't.
No. Okay, no problem. So yeah, so I think we are clear now. So first phase target selection, um, system decides which element gets the focus. Then route construction, so it decides that the route that will be constructed, which will be, what is that called? Event dispatch chain, which is the path from the stage to the source node. Source node is this. Then in the capturing phase, the event travels from the root node up until the target node, and in during its traversal, if it encounters any of the nodes which have a filter for that particular event. So one event is firing. So for that event, if there's a filter registered, it's going to get fired. Then from here, in bubbling phase, the event travels from the source node to the root node, and if it encounters any of the um, events that's been attached, sorry, any of the filters been attached to that event, then it's going to get fired. Cool. Oh my god, do we have to write example also? Oh no. I don't know why this slide is not blue then. I doubt we are going to get a lot of time on Friday night for studying. I doubt that, because we'll be tired giving exam, preparing in the morning. We'll be
Yeah.
exhausted. Yeah. Cool. So event handling extends frame, implements action listener, text field, event handling, new text field, set bounds, new button, show, set bounds, action listener, this, add button, add text field, set size, set layout, set visible, and the text field dot set, hello world, and the new event handling. So new event handling is going to instantiate the event handling class, creating an object, and here we are registering an event onto the text field. Uh, no, not on the text field, but we are registering a listener on the button. When that button is clicked, action perform function will be called, and it's going to set the text value of the input of the text field to hello world. That's what's happening. And we are pulling awt.all and awt.event. So remember that if we learn this example, even if they ask us to basically give an example of a Java FX application, I think we should be able to do that, because it's setting the layout and creating the elements. So it's a good example. Training over there also.
Yes.
Okay. Okay, Samaya, I like to read. I like you to read. I'm tired a bit.
Okay. JavaFX and its features. JavaFX is a Java library used to develop desktop applications as well as rich internet applications. The applications built in JavaFX can run on multiple platforms, including web, mobile, and desktop. JavaFX is intended to replace Swing in Java applications as a GUI framework.
GUI ni
However,
GUI.
however, it
UI.
provides more
Okay.
uh, it provides more functionalities than Swing. Unlike Swing, JavaFX also provides its own components and doesn't depend upon the operating system. It is lightweight and hardware accelerated.
You know what's the full form of GUI?
Yes, graphical user interface.
Correct. I think when we were studying Java, like properly, not rushing into it, we established that some of the like Swing, yeah, I think Swing and FX had a feature wherein they were not platform dependent.
Yeah.
So that's what he's talking about.
It supports various operating systems, including Windows, Linux, and macOS. Web pages can be embedded with JavaFX applications. JavaFX code can be embedded with the CSS to improve the style of the application.
So if I have to tell you how to remember these things in the examination, the best way to remember what to put is to think about what do you know, what all do you know about JavaFX. Just go ahead and put everything about that. Okay, so of course you know that it's a Java library. You know it has different components. We just saw that it got like text field and button and all of those stuff. You can give example here. We have established that out of all the applications that are available, in fact, all the libraries that are available to build Java applications, JavaFX is one of the best. So, it's platform agnostic. It's not dependent on the platform. It supports different operating system. We know that we can apply CSS into it. You can maybe write about events also there, like you can apply different events listeners on different elements. So just whatever you know about JavaFX, just go ahead and put that. Maybe just write some of the codes also, an example of a JavaFX application also. Yeah, so I think that way we can remember this. So used to develop
Yeah,
desktop application as well as rich internet application. These application can run on multiple platforms. It's a repetition. Mobile, yeah, this is a good point. Web, mobile, and desktop. Right, just write once and just run everywhere. So if you're doing it through other applications, maybe just works for web, but here it works for mobile also. So you don't have to write like multiple times. Uh, it can replace Swing because it's better than that. Provides more functionality than Swing. So here you can not only talk about the component has the fact that it's doesn't depend on the platform or operating system, but it is also better than Swing because it has more functionality than Swing. It has more component than Swing. Yeah, so you can talk about a little bit of difference also, and it supports various operating system. Web page can be embedded in JavaFX application, and of course you can uh, code can be embedded with CSS to improve the style of the application. Stage is all at the top. That's why when we were talking about the, what do you call it, the capturing phase, it was saying that it most traverses from the stage to the source node. Stage is at the top, then you have scene and scene graph. This is a good diagram. I think if we create this diagram for Java features, it probably might help. Not sure. Let's put that here rather than keeping it there. Okay. Okay. We talk about different components. So I think we established that it has layout and it has UI also. We divided the JavaFX application into multiple pieces. Like, let's see. Yeah, GUI of every desktop application mainly considers the UI elements, which I just spoke about, and then layout. Oh, there's behavior also. Okay. UI elements are the one which are actually shown to the user for interaction and information exchange. So a text node will probably give information to the user, like give heading, give paragraph information, um, or a button is also a UI element which will allow them to interact with it. The layout, we already spoke about. Layout kind of organizes all the UI elements on the screen, kind of wraps them together. And then behavior, which is basically what's going to happen when an event occurs. When the user clicks on a button, for example, what's going to happen. So that's a behavior. So three things. You have the layout. I think we should start with the layout probably. No, UI elements is fine because it wraps that. So UI element, layout, and behavior. So may I go and read?
Should I read it again?
No, from the package.
Okay. The package JavaFX.scene.control provides all the necessary classes for the UI components like button, label, etc. Every class represents a specific UI control and defines some methods for their styling. You
Okay,
see the UI components.
so to tell you that this slide here, the only thing that you can use when they ask you about user interface components is this guy, which is all the elements are there in the Java scene control. This information is just to help you understand. It's kind of giving you, um, it's like you are asked about Bahubali 2 without watching Bahubali 1. So it's like, so it gives you information before that, uh, kind of gives you the context before you start talking about the UI elements. So you can use this information. JavaFX.scene.control provides all the necessary classes. You can start from here. And then you can use this also. I think every class represents a specific UI control, defines some methods for styling, and then
Okay.
basically give the list of all these items. This should have been in blue. I don't know why it's not in blue. Text. I'd like you to read this. It's pretty self-explanatory. Uh, but let's just read this.
Okay. Label Label is a component that's used to define simple text on the screen. Typically, a label is placed with the node it describes. Button is a
Mhm.
component that controls the function of the application. Button class is used to create a label button. Radio button is used to provide various options to the user. The user can only choose one option among all. A radio button is either selected or deselected. Checkbox is used to get the kind of information from the user which contains various choices. User marks the checkbox either on or off. Text field is basically used to get the input from the user in the form of text. Java effects.scene.control.text field represents text field. Password field is used to get the user's password. Whatever is typed in the password field is not shown on the screen to anyone. Hyperlink is used to refer any of the web page through your application. It is represented by the class javaeffects.scene.control.hyperlink. Slider is used to provide a pane of options to the user in a graphical form. where the user needs to move a slider over the range of values to select one of them. Progress bar is used to show the work progress to the user. It is represented by the class javafx.scene.control.progress bar. Instead of showing a progress indicator, instead of showing the analog progress to the user, it shows the digital progress so that user may know the amount of work done in percentage. A scroll bar is used to provide a scroll bar to the user so that the user can scroll down the application pages. A menu Java provides a menu class to implement menus. Menu is the main component of any application. Tooltip is used to provide hint to the user about any component. It is mainly used to provide hints about the text fields or password fields being used in the application.
Okay, so we have label, that's for text. We have button for interaction. Radio allows the user to choose different options, check boxes, true or false options. Text field, take the user input. Password field, again, take the user's password, but it will be encrypted. User cannot see it in asterisk format. Hyperlink used to refer any of the web page through your application. And then slider used to provide pane of options, gives you range of values for them to select it. Progress bar is used to show the work progress. And progress indicator is used to showing the analog progress to the user. Scroll bar is used to provide scroll bar to the user. Menu is used to implement menus. And tooltip is used to provide hint to the user about that particular component. Yeah, so you have to try to remember these elements. Best way I can suggest how you can remember these elements is think about a web page, like think about a maybe a website. Like what are the key components in the website? You generally have a button, you have a input field to type something, you have a password field for logging in, you have progress bars, you have scroll bars when you scroll it, you have the menu item of the top, you have tool tips to describe about a particular element. So yeah, just think about the website, and you'll be able to basically remember those components. Okay. Okay, please read.
A list interface extends the collection interface, and hence it comprises all the methods available in collection interface. It is used to manage the ordered collection of objects. List preserves the insertion order and allows duplicate values to be stored. Elements can be accessed by referring to their position in the list with zero-based index. This interface comprises different methods that enable easy manipulation of elements based on the element index. Various methods defined by list interface are add all, get, index of, iterator.
Right. So it's an interface that extends collection interface, and it has all that method that collection interface offers. And it manages the ordered collection of objects, preserves the insertion order, allows duplicate um, access by referring to the positions. You can access it by the index. So when you think of list, think of array also at that point of time, and that will help you write some content about that. It has different methods that enable easy manipulation of elements based on elements index. Methods are like add all, get, index of, and iterator. Oh, one more. List interface is implemented by vector, array list, and linked list classes. Okay, go on. Can you explain this?
Yeah, an example of array list class which implements the list interface. We have a class list example with the main method creating a list a list using the list interface, instantiating using new array list. It contains strings, so we put string in angle brackets. Then add elements in the list. List.add mango, apple, banana, grapes. Then iterate the list elements using for each loop. So you can iterate a list using this syntax: string fruit in colon list, and print each fruit.
Where did the word fruit come from?
It's the string, the element that you're iterating.
Oh, okay, fine.
So like first it's mango, then apple, then banana.
Yeah, yeah. I'm just saying like there's no variable called fruit here. I'm just thinking that is it like
It
creating an
came from
alias
the
for
loop,
that?
from
Okay,
this for each loop.
okay.
It's
Yeah, yeah.
created
Of
there.
course. Okay, okay. So I think what's happening here, you have to pass the array, and how in an array you get a variable like any you can name it whatever you want, and that has the value during each iteration, right?
Yes,
So
like
that's
in
what it is.
Python we had like for I in
Ec-
array like that.
Yeah, exactly, exactly. So think of this colon as in, and that list. So then we are using. You can name it whatever you want. Okay. Moving on. There's so much in Java. There's so much, and there's so little in DSA, which scares me. Okay, let's just read this.
Use of map and hash map. Uh, Use of maps are perfect to use for key value association mapping, such as dictionaries.
Mm-hmm.
It is used when we need fast lookups. The maps are used to perform lookups by keys or when someone wants to retrieve and update elements by keys. For example, a map of zip codes and cities, errors and their descriptions, etc.
Okay.
The use of a hash map. The hashmap class of the Java Collections framework provides the functionality of the hash table data structure.
Okay.
It stores elements in key value pairs. Here, keys are unique identifiers used to associate each value on a map. The hashmap class implements the map interface. It is non-synchronized. The advantage of hash table is that the time for basic operations like get and put remains constant irrespective of size of the map.
Okay. So maps are perfect use of for key value association mapping, such as dictionaries. Used for fast lookup, maps are used to perform lookup by keys to retrieve and update elements by keys, like map of zip codes and cities, errors, and their descriptions. HashMap class provides functionality of the hash table data structure, stores elements in key value pairs. Keys are unique identifiers. HashMap class implements map interface and it's non-synchronized. And the advantage is that time for basic operation like get and put remain constant, irrespective of the size of the map. Okay, let's do date and time. So I think date and time is used to basically get the date and the time. Uh, you can instantiate a class called datetime to create a datetime object, and then you can retrieve the current time, and you can also perform different operations on that. Like, for example, you can compare two dates. You can also pass in your date in form of a timestamp in milliseconds, and then that'll give you the date, and you can perform date operation on that. You can get the day, month, year, all of that stuff. So Java supports creating and modifying date and time using primarily two packages, which is java.time and java.util. Java.time was part of Java 8 release and was introduced the new immutable solving the shortcomings of legacy java.util.date and java.util.calendar classes. Okay, so you have two things. You have date and you have date long milliseconds. This creates, these are constructors, creates a date object representing current date and time, and this will be creates a date object for given millisecond since January the 1st, 1970, and that's 00000 GMT. Different methods like you have after, um, test if the current date is after the given date, before, test if the current date is before the given date, clones the date, compare to compares the date with the given date, equals check if two dates are equal, from returns an instance of the date object, from instance date, get time returns the time represented by the state object. So yeah, I think if you can give few example from this, that should be fine. And there's a date and class program also that you can write. So hey, is this correct? I think it's incorrect, right? This um this guy should be here, right?
I think both are correct.
Both are correct. Okay.
Yeah, they both work.
Create an object of a date class like so, print that, then get the time, print that in milliseconds. So get time gets the time in milliseconds. Create another date, but this time use your own timestamp, get the time, and then compare it. So date dot compare to, and then put the second date object there. Get the result. If result equals 0, say that both dates are same. So this return, if compare to returns 0, this means both are same. If it returns 1, then um, the first one which you're comparing to it, this one is later than this one. Okay. uh, and then if it's any other um, value in the result, then this one is, sorry, this one is earlier than this one. Okay. Okay. Yeah, let's start from here. My god, when will this end? String class versus string buffer class. String class is immutable, string buffer class is mutable. String is slow and consumes more memory when we concatenate too many strings because every time it creates a new instance. String buffer is fast and consumes less memory when we concatenate strings. Don't you think they should have given us at least 3-4 days gap between Java because Java is too big? They put it back to back.
Yeah, but at least it's better than last time.
Yeah. Last
We
time,
had
what was the problem?
we had all three exams together, and I think only 1 day gap between two of them.
Oh, okay. No problem. Anyways, string class overrides equals method of the object class. So you can compare the contents of two strings equal methods. String buffer does not override the equal methods of class. String class is slower while performing concatenation operations. String buffer class is faster while performing concatenation operations. String class uses string constant pool and string buffer uses heap memory. So I think the thing with the heap memory, you generally use heap memory when you want to dynamically allocate memory. Okay, so just to recap, string class is immutable, string buffer is mutable, which is changeable, and string class is slow, consumes more memory while performing concatenation operation. The reverse is true for string buffer. String classes class overrides equals methods of the object class. You can compare contents of two strings by equals method. String buffer class cannot or does not override the equals method of the object class. String class is slower by, okay, we already did that. String class uses string constant pool. String buffer uses heap memory. Okay, Sumaya, let's read this.
Java file class. The file class is an abstract representation of file and directory path name. A path name can be either absolute or relative.
Okay, so file class is the abstract representation of file and directory path name. Okay.
The file class has several methods for working with directories and files, such as creating new directories or files, deleting and renaming directories or files, listing the contents of a directory, etc.
Okay.
Two file class methods: can write tests whether the file is modifiable or not, can read tests whether the file is readable or not.
Okay. I'm going to recap. So it's an abstract representation of file and directory path name. Abstract representation of the file and the directory path name. Of course, we know that path name can be either absolute or relative path, and it can have several methods for working with directories and files. Okay, such as creating a new directory, deleting, renaming, listing contents of the directory. So it has several methods for working with the directories and files, such as creating a new directory, renaming the directory, listing the contents of the directory, and deleting it as well. So basically, CRUD. Can write and can read. So can write test whether file is modifiable. Can read test whether the file is readable. Java IO exception. Why is it blue? Is it in the examination paper? IO exception means any input output exception can occur while reading a file or writing a file, basically accessing a file system. Okay. So when you're accessing a file system, an exception can occur. Java IO exception extends the Java exception class to get the serializable form. The Java interface serializable is implemented by the class that extends IO exception. This is useful when you have custom exception classes for your project. File input stream myfile.text print catch IO exception print get message. For a program to exit gracefully in an exception case, we should surround it using try and catch block. It also means IO exception is a checked exception. So we already did exception, right? Which is basically an event that occurs when something out of ordinary happens during the execution of the file. That was the exception. But this is being specific, called Java IO exception, which basically occurs when we are handling files. Okay, so may I read this, please?
Java IO stream and different stream classes. Java
Mhm.
provides IO streams to read and write data. A stream means continuous flow of data. A stream represents an input source or an output destination, which could be a file, IO device, other program, etc. Java encapsulates stream under java.io package. Java defines two types of stream classes. Byte stream classes provides a convenient means for handling input and output of bytes. Character stream classes provide a convenient means for handling input and output of characters. Character stream uses Unicode and therefore can be internationalized.
Okay, so it provides IO streams to read and write data. Stream means continuous flow of data. So how you have, you know, what's the difference between river and pond?
A river flows.
Yeah, the water is stagnant in a pond, while the water is continuously flowing in a river. Some of the rivers are also called streams. So that's what the meaning of stream is: continuous flow of something. In this case, in programming, when you talk about streams, you're talking about continuous flow of data. Like a YouTube, when you're watching YouTube, it's not gonna load the entire video at once, because that'll kind of use up all your internet. Video might be like 3 hours. You're not going to load 3 hours if he's going to watch only for 10 minutes. Like sometimes I watch a movie, I take around about a week to watch a movie, because I watch it for like half an hour and then I do something else. Then another day I'll watch for another half an hour, and so on and so forth. So that's why the stream is pretty useful. You have a continuous flow of data, and it's only flown basis the requirement. So a stream represents an input source and or an output destination, which could be a file, IO device, other program. Java encapsulates stream under java.io package. Java defines two types of stream classes: byte stream and character stream. Byte stream classes provide convenient means for handling input and output of byte, and character stream classes provide a convenient means of handling input and output of characters. Character stream uses a Unicode and therefore it can be internationalized. Okay, so provides IO stream to read and write data. Stream means continuous flow of data. Stream represents an input source and output destination, which could be a file. Java encapsulates streams under java.io package, defines two types of streams: byte stream and character stream. Byte stream provides means of handling input out of the byte, output of the byte, and character stream is handling input and output of characters. We'll stop at 11:15. Okay, so in like almost 5 6 minutes,
Okay.
because I'm really tired. Byte stream is defined by using two abstract class at the top of the hierarchy. They are input stream and output stream, and these two classes have several concrete classes that handle various devices, such as disk file, network connection. Some byte stream classes are buffered input stream, buffered output stream, data input stream, data output stream. These classes define several key methods. Two most important are read, which reads byte of data, write, writes byte of data. So it's asking us to describe different stream classes. We talked at the high level, we talked about two, which is byte stream class, which is means for handling input and output of byte, and this is handling input and output of characters. Byte stream class has two subclasses, which is input stream and output stream, and character stream class has reader and writer. Um, they have several concrete classes that handle various devices such as disk files, network connection, and some of the examples are these guys. Two most important methods are read and write. Okay. Okay, again, this is defined by two abstract classes, reader and writer. These two abstract classes have concrete classes that handle Unicode character. So here, the concrete classes handle various devices such as files and network connection. Here, they handle Unicode character. Some character stream classes are buffer reader, buffer writer, file reader, file writer. Read method is used with buffer reader object to read characters, and this function returns the integer type value. It has what we need to use typecasting to convert it to char type. Program to save given data. We import the buffer input stream, file output stream, IO exception. We create an input stream using buffered input stream. We create a variable called bytes, which will be an array of the size 1024. We print enter your data. We read it using input stream, passing bytes. So bytes will hold whatever data user has entered. Then we instantiate file output stream, pass the path where we want to save the data, or the path of the file where we want to save the data, hold it under out object, and then instantiate buffered output stream, pass the out into this, and hold this against output stream. We call the method write, and we write whatever data we have received here. So it's going to in turn go and find out that file from here because we have passed out, and then it's going to put that information there. Then we flush it and then print data saved in the file. Object serialization is a mechanism of converting the state of an object into a byte stream. In object serialization, an object can be represented as a sequence of bytes that includes the object data as well as information about the object's type and the types of the data stored in the object. I'm pretty sure this is very important. This might come in the exam, object serialization. After and also event might come. After a serialized object has been written into a file, it can be read from the file and deserialized. That is, the information and the bytes that represent the object and its data can be used to recreate the object memory. So basically, an object that's been serialized can be unserialized. During serialization, the object is converted into a byte stream, and which can be saved on the file, transferred to another JVM, and during deserialization, we convert the byte stream back to the original object. How does it work? An object is eligible for serialization if and only if its class or its parent implements the java.io.serializable or java.io.externalizable interface. How can you create a thread? For a thread also there was a eligibility, right? You have to do either this or that. Do you remember what was that?
You have to extend the thread class or implement the runnable interface.
Perfect. Here, for an object to be eligible for serialization, uh, if that will only happen if its class or its parent class implements either serializable or externalizable library interface. So here it's interfaces. There's no class extension. It is just implementation of serializable, which comes from this word serialization, externalizable. In the serialization process, we convert an object state into a byte stream so that it can be transferred from one JVM to another, which I said earlier. You can transfer from one JVM to another and revert the byte stream back to the original object. Serializable is a marker interface, contains no method. We already know an interface does. Oh, sorry, yeah. This interface doesn't contain any method that tells JVM that the object of this class is ready for being written to and read from a persistent storage over a network. By default, JVM takes care of writing and reading the serializable object. The serialization and deserialization are via following two methods. One is object output stream dot write object that writes the serializable object to the output stream, and object input stream read object that reads the constructs and returns an object from the input stream. Uses. So may I just read this?
Use of object serialization in Java. Communication. If you have two machines that are running the same code and they need to communicate, an easy way is for one machine to build an object with information that it would like to transmit and then serialize that object to the other machine. It's not the best method for communication, but it gets the job done.
Okay, so if two machines they are running the same code, they need to communicate. Easy ways to build an object, put the information about that object you like to transmit, and then serialize it to another machine. I think we discussed that if, while storing the data into database, the serialization is also a good option, right? Persistent. Yeah.
Yes. Persistence. If you want to store the state of a particular operation in a database, it can be easily serialized to a byte array and stored in the database for later retrieval.
Mm-hmm.
Deep copy. If you need an exact replica of an object and don't want to go to the trouble of writing your own specialized clone class, simply serializing the object to a byte array and then deserializing it to another object achieves this goal. Caching, really just an application of the above, but sometimes an object takes 10 minutes to build but would only take 10 seconds to deserialize. So rather than hold on to the giant object in memory, just cache it out to a file via serialization and read it later when it's needed.
Hmm. So what this is saying is that it takes 10 minutes to build an object from its like original source. But if you keep it in the serialized format, it only takes 10 seconds to deserialize the object. So the process of deserialization is shorter compared to building an object. So just keep it in the serialized form, and when you need it, you can deserialize it because it takes less time. Okay. So rather than holding a giant object in the memory, just cache it out by serialization. Let me show you how that looks like. I'm going to